Welcome back. I hope everyone had a wonderful Labor Day weekend. I know I did because there was a big flea market over it, and one of the few things I managed to walk away with was this amazing little piece of equipment. This is a 1948 Montgomery Ward's Airline portable television. I have to excuse the knobs here. I pulled these off of a junk GE radio. It's just a really cool little unit. It's got a 7-inch picture tube in it, and I'll have to put the official designation in the title because I don't have it on me right now. It's some long, complicated deal. Either way, I just think these little portables from this time period are really, really cool. This is not a Channel 1 set, so it's got 2 through 13. It's got a brass silk-screened scutcheon on the front here. This does use a 7JP4. It is an electrostatic set. We'll get inside it in just a minute. But it uses 2 separate chassis. So the lower, here with all the guts, or sorry, with all the knobs, is the IF and the main power supply and all of that. And then the 7JP4 is actually mounted on this side of the cabinet with its own separate chassis, providing the high voltage for the picture tube, as well as I think it's also dealing with not dealing with the sync separation. I think it's purely just the vertical and horizontal drives. A number of octal tubes on that, and then the rest is pretty much all miniatures. Cabinet, unfortunately, is in this Tovex, I forget what it's called. This leatherish fabric material here. I believe you can actually get this stuff for doing guitar amps and the like. And unfortunately, the control markings on the back for all the various bits has been damaged. That's just masonite. And yeah, we've got some external antenna connections. Then you can see our vertical chassis here with all of our main bits. This did have a safety cord interlock. Someone ripped the plug off, so we'll have to replace that. But overall, it's not in bad shape. I do love the giant Jones connector that was installed there, and this single tip jack connection which comes off the CRT. I don't think that's the video signal. I'll have to check the schematic. Well, we got a great big ground lug right here. But yeah, there's not really much to it. It's probably on the same range of complicated as a Motorola VT71 that I have a stack of at home that I haven't touched yet. But I'm going to do this one first, so I have a little bit of experience with electrostatic sets. After all, I've done 2 electromagnetic, so this should be much simpler, right? So I'm going to finagle getting the chassis out of this and get them up on the bench. Okay, front and center is the IF-RF chassis, the lower. So we've got our tuner section here, which is on a separate assembly for all the coils. We've got a wonderful spider egg sac right there that I should get rid of. That's the contrast control, I think. Yeah, I think it's contrast, brightness, and power and volume are over here. This speaker does have a bit of a tear on this part of the cone. It looked like someone tried to repair with rubber cement. I'll have to go back over that. And one thing that did surprise me about this, flip this around here, if you'll notice, unlike some other TVs, like the Motorola of the time period, this actually uses a power transformer, which in a portable is actually kind of surprising. The rating is 165 watts in this whole set. Let me actually stand this up a little bit so you can see. Now, one of the things I have to deal with is the fact that someone was working on it previously and apparently did not feel it was necessary to put all the tubes back. I dug through my collection. I don't carry miniatures very often, so I'm still missing these 2. I forget what they are. They're a relatively common TV tube. There's one 3-section electrolytic on here. That'll have to be replaced. And so we got the male Jones plug there. Let's rotate it around and get a look underneath. Now, this does not have a standard rectifier tube. Oop, that's too far away. Sorry. This does not have a standard rectifier tube set up. This actually uses seleniums. So if I get the light in there good enough. Actually, let's not use this one. being fancy today. We'll use the ring light. There we go. So you can see we have one of them here. There. We also have a 3-section can dome resistor. Or, no, this is a 2-section can dome resistor that I'll probably just wind up replacing. If it's still good, then we'll leave it alone. But you never know. And most of the sections are attaching to this electrolytic right here, so that's going to wind up going on a terminal strip. And I'm debating on whether or not to leave the seleniums in place. If they go, they apparently smell pretty rancid. I haven't had one fail on me yet, but, you know, it's just one of those, sort of a preemptive strike. And as far as wax capacitors go, there's a good few in here. You know, 1, 2, 3, 4, maybe a dozen on this lower chassis. There are a pair of safety caps across the line right here, I believe, because this plug, the line cord connection, goes into the upper chassis, which I'll take a look at, and then comes down through the Jones plug, goes over to the power switch, and then goes to the power transformer, and then B+ and all the other connections go back up through the Jones plug. So you got to have a good solid connection here, and so those guys, those are going to have to get replaced with Ys, Y2 caps for safety, and all of these are pretty typical, although, ooh, I don't have any more .25s. I'm going to have to put it in order for some of those from Mauser. And we got a number of ceramic disc capacitors that the wax coating on seems to have bubbled a little bit. And some of these big guys, I doubt these are in spec anymore. I'll end up going through and checking all of those. This does appear to be a choke in the B+ circuit, if I looked at it right. And I'll also need to take a look at this resistor right here. Oops, sorry. Here. This is actually coming off of the selenium rectifier and going straight into the first part of the electrolytic. So if that goes too high, we can see the B+ sag pretty badly. So this one is significantly lighter than the lower, because really all we have is the CRT. I mean, this doesn't weigh anything. The shadow mask in this actually was in fantastic shape, although it was glued to the CRT, and with a little bit of gentle prying, I was able to pop it away, and it didn't just disintegrate like the ones in my Motorola's. They are water soluble, apparently. So this is where most of the octal tubes are. So we do have a few 6SN7s. I think there's 3 6SN7s on here. Here, here, and here. And then one of these, no, sorry, these 3 are 6SN7s. This one is a 6SL7. And then we have a 6Y6 hiding back here. Other end of the Jones plug. We have the high voltage cage, which we can bring around and pop cap off. So this just has a number of little screws, and according to the warning sticker, these screws, all 9 of them, should be in place at all times. I'm missing, I think, half of them. So no one really bothered to put them back. Oh well. And there we go. So on the electrostatic sets, from what I understand, instead of a typical flyback, well, I guess this is a flyback in that respect. We have a 6X5 here that's providing the initial rectification for this, or no, is this using being a voltage doubler? I gotta bring out the schematic, I don't actually know. But what's neat is if we take a look at this little coil of wire, the 1B3 is a pretty typical high voltage damper, high voltage rectifier for the B++ for the actual tube, for the deflection plates and everything in here. So it's about 6,000, well, not quite 6,000 volts, a little less than that, maybe 4? It's, compared to an electromagnetic set, it's a fraction of the output voltage. But what's neat is, you see this little ring right here. In order for this whole circuit to oscillate and produce the high voltage, you need feedback. So the solution to this, apparently, and like on the Motorola's and other sets, is to put this ring around here as a pickup, so when you get when you get current flowing through the 1B3 on the output side of things, this inductively picks up that pulse going from anode to cathode and triggers the negative feedback. It's just kind of cool. And then you can actually adjust how much feedback you get by moving the coil up and down on the outside of the tube. I just think that's a kind of a neat way of doing things. And it does look like, yeah, there's a few wax caps hiding under there, but this platform comes off with a few 1/4-inch machine or self-tapping screws, so that shouldn't be too big of a deal. There is one inductor under there. That's probably okay. Now let's flip the whole assembly up here and see what we got underneath. Okay, let me bring this in. So on the lower right we have 2 more selenium rectifiers. We have another choke. This is one of the few electrolytics, the axial lead, that are under here. What's this one rated at? So there are 2 on the top, here and here. That one is toast. It's already starting to leak the black goo. This one, if I get this out of the way, that one isn't showing signs of death yet, but I'm sure it's on the way out. These are, or at least that one, is insulated from the chassis. That one, no, that one's connected to chassis. So just this guy here. So that's probably going to be insulated for some bias voltage. I did actually try powering this up on a Variac briefly, but I stopped when I heard a bit of a snap, crackle, and pop somewhere in here. It happened for like a split second, and judging from the goo leaking out of that one black beauty, there's a possibility that was the culprit right there. But then we see the most expensive part of this is going to be these guys. So these right here are the caps that are in the deflection plate circuit. So most of these potentiometers back here, in fact, these 3 up here with the insulated handles, all of these are really just setting up giant voltage dividers for the B++ for the tube, for the picture tube. And then all of these guys are in the plate circuit. So these are all rated at 6,000 volts DC. These are, what are they? 0.0, the wax is screwed up, can't read that. 0.03. I'll have to check the paperwork and see if that is correct. And then there's a few of these. Yeah, that's this is a later one. That's 0.01. Let's see, what about this? That's a Sprague 6000 0.05. So a little bit of work has been done to this. These Mallory's, these are getting replacements. This is a later replacement. This is, what on earth is this? 0.1, no. 1 microfarad? 200 volt? Maybe? Huh. There's most of the marking's been rubbed off. And then there's a few more little wax caps in here, a number of these molded blocks that I'm hoping are micas and not just mica molds. And then, oh, the power receptacle is right here. You just barely see that. And then that's going up into the Jones plug. So all in all, I mean, that's it. There's not a lot to this, which means that rebuilding it should be pretty straightforward. Although I'll probably need to double check on and clean. I'll need to clean all of these controls up here because I'm sure the carbon tracks aren't in the best shape, and we'll need to make sure that all of these are in good shape. Although it is a little concerning that this leg, where they're all joined together here, is floating really close to the chassis surface. There's no evidence of there being any arcing there, but again, you're talking a few thousand volts. I would at least like to be safe with these. But yeah, that's about it. So I think the next thing to do is hop on Mauser and start ordering some high voltage caps to deal with that, and I need to dig through my electrolytics and see what I have. So before I go any further with this, I wanted to make a few notes on some stuff that I just did during the time lapse. I got all of the main paper caps swapped out. These two back here in the corner, bit of a pain. This one down here is, I believe, a 0.05. This is a normal 400 volt rated cap, put it in a 630. This one, these orange drops, however, these are rated at 1600 volts to replace the original 1200 volt paper caps. So it's worth noting a few of these are higher voltage, and then of course we have these guys, which are 6000 volt rated for the deflection circuits in the for the picture tube. And the next thing I want to do under here before I start messing inside the high voltage cage, because there are some caps trapped underneath it, is there are 4 resistors in here that I'm going to be swapping out. These two right here and these two right here. Now, the schematic that I'm working from is actually a revised edition from Sentinel themselves, who actually built the chassis for this Airline television. And they swapped out these two guys right here, which on the schematic it's 4.7 mega ohms. These, I believe, were about 4700. I had to grab my little color wheel and double check again. Either way, not quite as high. Or no, I think these were... anyway, you can tell that from the bodies they're fairly large. The schematic, the older schematic, apparently lists them as 2... Well, actually, I don't have the old schematic. What am I talking about? The new schematic that I have, the revised edition, lists these as half-watt high-voltage resistors. But they didn't specify what high voltage means in terms of breakdown voltage, because resistors, as I found out, do actually have operating voltages. Most of the little carbon comps in here, you know, the wattage rating is usually a good indication of what kind of breakdown voltage it has. And these big guys over here are in the 2-watt range, and they can usually handle a decent amount of voltage based on what everyone else online has said. And the recommendation to me was that I just needed to swap these out with some 2-watt carbon comps. Assuming you can actually find them, because these days carbon composition resistors don't generally come in large values like that. However, companies like Vishay, for example, make brand new high voltage resistors. These are actually recommended to me by Bob Anderson over at B. Anderson TV. Great channel. And yeah, these are half-watt, 4.7 meg, with a breakdown voltage of, I want to say, about 7,500, which is pretty damn good. Now, I did do a little bit of math to determine the amount of current flowing through here, because I figured it's this voltage being applied to the, what is it, the vertical amplifier tube? Yeah, this is the 6SL7 vertical amplifier tube. And these two resistors here are actually coming off the tail end of the a string of resistors that come directly from the high voltage power supply. It comes through a ladder of resistors down here, and eventually, by the time it gets down to here, the voltage across the 4.7s would be, I think I calculated like 1600 volts. Not a ton. And I went through and I determined that the current through it is pretty negligible. The half-watt rating was actually over double what it really needed, so it works out. So that's all well and good. I'll be replacing those with that. These guys over here, these on the revised schematic are supposed to be 100 kilo ohms. These, I believe, are 8200, and they've drifted pretty badly. Or 82,000. I don't remember. Don't listen to me. It's been a little while. My Mauser order got lost in the mail, and I had to reorder all this crap a second time, so it's been a week or two. I do, however, have some 2-watt carbon films, and I looked at the schematic and just sort of looked at it and said, yeah, no, these aren't going to be any real danger. I don't need to go crazy with the voltage rating. These are actually going to the plate of the 6SN7 horizontal amplifier. And I took a look at the, let's see, those are coming off of there. But unlike these, The parts list does not give these components a high voltage rating. It remains to be seen whether or not that's because they're 2 watts, but it just seems odd to me that they wouldn't just put a high voltage rating for both. But let me just double check here. Make myself a liar. That is R5 and R2, 100,000 ohms. Oh, and here I suppose I ought to show off my parts list here. Let's see, R5, 100,000 watt, sorry, 100,000 ohm, 2 watt. Nothing special. Compare that with the ones I'm going to replace up here. Carbon, 4.7 mega ohm, high voltage, half watt. Well, that actually lists at least 4 of these. Interesting. 23, 24, 58, 59. Or resistor assembly consisting of 2 2.4 mega ohm resistors in series. Anyway, that covers the resistors that I got to deal with. The other things that I still have to deal with on the underside of the chassis here, other than these selenium rectifiers, I will not be able to deal with them until the unit's actually powered up and I have an idea how much current's flowing through them, how much voltage they have across them, so I can set up an appropriate replacement. But I still have these electrolytics. Now this one is a single section. It's 100 microfarads at 150 volts. I do have some nice new Nishikans to replace that with. I'll be doing that under here because there's enough space and I can just unhook this one lead off of the selenium rectifier assembly and just tie the negative leg to this lug. This capacitor here is actually a floating ground, so it is not tied to chassis. This one, on the other hand, is a 3-section electrolytic, and I think they're rated at 300 volts, and I've got 450s for that. This one, I don't know if you can see it here, has got wonderful crusty crap coming out of it because it is roached, and given how many connections there are going to it, I don't think I'm going to bother. Well, let me think about that. Got a common can there. It says there's a lot of these wires tied to this lug, and trying to migrate everything over somewhere else. I don't want to change the lead dress. My usual procedure for ones like this that are in a difficult spot is to just flip the chassis over, cut the can at the base, pop the top off. I'll drill holes next to each leg to pass the leads of the new radial caps down through, tie the negatives together, solder them to a lug, and then wrap the each individual leg around these guys once they're passed through. And then I did buy some skinny versions of Michigan caps. Where are they? I think, yeah. These are really... Whoops, no, that ain't it. These. So these are, where are these? These are 68 microfarad to replace the 160. These are really, really long, but they exchanged that for the diameter, so it's skinny, but you get a little bit of height there. So these work great if you're stuffing these that don't have a very big diameter. I'm not sure how well it'll fit. If it fits, no big deal. If it doesn't fit, I can live with it. It's on the inside of the cabinet anyway, and the cabinet's closed up. However, if I am able to fit it under there, what I like to do after putting the top of the can back on is to use a little bit of this thermal tape around the base to make the transition look a little less jagged and unnatural. Alright, I'm not going to lie, it's a little tricky to get a good view of this. So this is the underside of the high voltage cage here. I've just taken out all the screws along the edges. I did have to disconnect a few wires, notably the ones going through this hole here. So this red wire I've disconnected. I've desoldered these 2 wires from the 6x5 rectifier socket, and I clipped this white wire here from one of the controls to give me some slack. These guys I left in place, although I did accidentally trim one of them by mistake. I'll have to go back and fix that. But that does at least allow me to get to the final 5 caps hiding underneath this thing. So let's see what we've got here. I did inventory using the parts list. So this is one of the 1200 volt caps. I did make sure to, yes. Got a special bag with those wonderful little orange drop fellows. So one of these will be going here, there's another one here. In fact, all three of these are 1200 volt rated. And let me make sure I actually bought enough of them to do that. I believe I did. Now the other two that are underneath here, one of them's on the 6x6. So let's see. I did have to extract some mummified spiders from Anderson here. 400 volts, 0.1, no big deal there. This one, I think I looked at it earlier as well, and there's nothing very special about it. Yeah, another 0.1, 400 volt, so not that big of a deal. So these are all 0.01s, and I'm gonna have to go dig in the closet for some of these. A few things to point out here. These all went in pretty easily. I'm going to have to add some extensions to this wire. This wire I'm probably just going to have to outright replace because I clipped them, but they don't have a lot of extra slack left over. These guys can direct solder back in. Anyway, while I was in here, I made sure to test all of these little guys to make sure they're all within spec, which they were, except for this one resistor here, which is on the 6x6 output tube. Supposed to be 33 ohms, it drifted high to 50. It's only a, see, that's a silver band, so a 10% tolerance part. So, I just decided better off to chuck it, replace it, got a new one in there. Everything else looks good. Tried to do a little bit of polishing under here, but unfortunately the plating on this side of the chassis is pretty well toast. I could spend a lot of time trying to make it look pretty, but at the end of the day it's going to be closed up, no one's going to care. So I'm just going to try and wipe it down at least. I did also, if we come over here, I managed to pull the cardboard sleeve off of the multi-section electrolytic, and I was able to wipe most of the dirt off so I could see the original markings, because the important thing I need to know is the code here. So a triangle is 10 microfarads, square is 20, and the half circle is 60. That'll give me an idea of how to work on things. And now I need to bust out the Dremel, and I have also done this with a piece of hacksaw blade, but I don't have a hacksaw blade handy. So back on the top of the chassis, if we look over here, I've got the high voltage cage reinstalled. A little bit of dusting around here, got rid of the remainder of the spiders. And I have taken some time to lop off this can right here, which actually took a fair amount of effort because this thing was... These things are paper and foil. You'd think you'd be able to hack through them pretty good. On this one, the electrolyte was actually still a little sticky, but the bottom of it indicated that it was starting to die, and I'm not taking any chances. Now I got this cut off, and I started, I got all the junk out of the bottom of the base there, and I started hacking away at the inside, trying to heat it up, because in the past I'd normally just hold this over with a pair of pliers, heat it up, and let the stuff fall out. This one did not want to go. I drilled into it, I picked at it, I pulled at it, I got about a quarter of the way down in there, and then my brain turned back on, and I said, you know, isn't there a cardboard sleeve that goes over the top of this thing? You know, this one? Yeah, so that was a waste of time. It was probably a half hour of my life I'm not getting back. But it does mean I don't have to worry about using thermal tape or anything. I'll probably need to find a piece of cardstock. Oh, should I take that back? I don't need to find a piece of cardstock because there's one right here. I'll just cut a new circle, the inside diameter of this, get it up in there and glue it in place. Maybe a little bit of black magic marker to make it match the outside of this. And yeah, no one will ever know. Now as far as fitment goes, here are my 3 capacitors. We've got a 60, a 10, and a 20, or I should say, I don't aim for super specific values. I go for the closest common values. So these days 68 microfarads is more common than 60, 22 microfarads is more common than 20, but 10 is just, well, it's 10. So I bought a whole bunch of these because they come in handy. And if I squeeze them all together at the top, and we see what the overall outside diameter is going to be. Sorry if my fingers are blocking it. Oh yeah, there's plenty of room in there for these to sit as is. So I'll probably bring the bases up, join all of the negative leads toward the center, and then I need to drill 3 holes near each of these legs here and set it up so that the legs of these capacitors will easily feed through next to where they need to go. Now, if there's not enough room for that, I'll wind up having to make some short leads using solid either 22 or 20 gauge wire to bring them up through and attach that. There are some remnants of the old tabs in here. Those will go away, but they are good reference points as to where the actual connections are. So I'll probably need to drill more toward the inside here with a really small, usually a 1/16 of an inch bit, and then enlarge it as necessary. So I'm back on the underside here. I've got my 3 caps taped with a little bit of scotch together, and I have stuck the leads, probably hard to tell, stuck the leads through here in their respective positions. I've got the 3 legs here in the center that I'll eventually make a ground link to. So let me just wrap the positive legs around their respective posts really quickly. Now I need to flip this over and knock all the loose junk out of it into the bin. But that should cover the majority of this. Again, deal with these once it's up and running and I have an idea what I need to replace it with. As far as the video chassis goes, it's about all I really need to do to it. Oh, actually I take that back. There's one other thing I need to address. Or, 2 other things, one not as important as the other. I don't know if you've noticed, but the CRT socket back here has started to come apart on me. The pins, the contacts in this deal, the sockets I should say, have decided to liberate themselves from the back of this. Quite honestly, I cannot see any retention mechanism at all that would actually keep these things in place. They're just sitting in there. They're not tightly installed. They're just kind of gently overlapped over this piece of this bakelite ridge, and they just pop right out. Now, thankfully, they're all color coded, so I know where they go, or I know where they go for the most part. This one with the tip jack on it. This is the cathode connection for the CRT. That plugs into the RF the RF chassis, and then Oh joy, there's more than one black wire, and there's more than one red wire, and... oh shoot. Gonna have to go hunting and figure out where the heck everything connects. Hooray. Oh, I do that, I'll clean these up. That's not the thing I wanted to talk about. What I wanted to talk about is this. This is the Jones connector. Am I even in frame? Yeah. This is the Jones connector that goes between the two chassis. And all the rest of these wires are cloth covered except for these two right here, that, as you can see, are extremely brittle. This is the zip cord for the power cord, actually. So we have our plug right there. That we would normally have an interlock style connector. So when you open the back of the TV, it pulls the plug out of it and shuts it off for safety. And these are toast. So this is complete junk. I started noticing it was cracking off going all the way into here, and it just connects right there. So I'm going to need to replace that before I can even apply power to this, because that's just downright unsafe. Now I suppose while we're here, I might as well show a little up close now of the installed capacitors. That doesn't look too bad. And then of course we take its nice little hat right here and we stick that over the top. And from the side, I might not even have put a top on it. You know, it looks just fine like that because the chassis will be sitting like this in the actual cabinet. Yeah. That's there. I need to do some hunting, and I also need to figure out how on earth to take this Jones connector apart. It's only got one pin right here. I don't think I have... Let me see if I can push on it a little bit. These Jones connectors always seem like the sorts of things that go together once and you don't take them apart again. Maybe I can extract this. Maybe. Looks like it might. Just might. Don't have a proper pair of pliers handy. There it goes. Alright, so there's the pin. I should be able to just coax the end of it out just a little bit. And slide it up, and there we go. Okay. So the power is connected, and these are nicely numbered on the inside. Connected to pins 10 and 9. Alright. So that's easy. And I'm just going to go ahead and do this right now, just because I don't need to forget. Now I need to find some zip cord to replace it with. Oh, and I'll have to take this off here and get rid of all that bit. Okay, so I've got the connections repaired to the socket. Well, put them back where they're supposed to be because the schematic thankfully is labeled with colors and pin numbers. CRT put back on the chassis, clamped back in place temporarily because it sits at a funky angle and I don't know exactly where it needs to be yet. And I have replaced the original wiring into there. I tried using a piece of zip cord. The problem was modern zip cords you get have much thicker insulation on them than older zip cords do, and trying to cram one of those into this hole with the rest of these wires was not happening. So I just went with some, what is this? This looks like 18 gauge wire stranded, and that worked out just fine. Soldered them into the Jones connector end, got it soldered back underneath here, no big deal. So that will take care of that. I do need to get a replacement for this, the cable tie, because that's all kinds of gone. Yeah, alright, there we go. Populated. So that is about going to do it for this segment. That's going to cover the work on the picture tube chassis. In the next episode, I will start tearing into the RF chassis and getting it to the point where I can at least hook the two together and see if we have a raster going on, and then I can deal with sourcing the remaining tubes and getting a signal through it. But until then, Thank you for watching.